Alright, so now that we know about molar mass and Avogadro's number, we can do a lot of fun different chemistry problems. Yay! Converting is the heart and soul of all these problems. Dimensional analysis is definitely one of those ways that we can solve these problems. But so is this lovely map to Moleville that I created for you. Looking at the map to Moleville, at the top is Leaderland, and Leaderland is closed, as it says, until second semester. We'll deal with that aspect of the mole when we get to gas laws and gas equations. So what we really want to focus on is Particle Town, Mass City, and Moleville. Particle Town over here, when we're doing problems that have these buzzwords, atoms, ions, molecules, or formula units, then you know that you're talking about the number of particles. And that is when we're going to be using Avogadro Avenue, Avogadro's number. Okay, and that is right there for you, 6.02 times 10 to the 23rd. If you are over here in Mass City, then you're going to be solving problems that involve things that say mass or in grams. And when you're going to be working with that, then you're going to be using the molar mass from the periodic table in order to solve those problems. Now at the bottom you'll notice, and you'll see it on the arrows going between the places, but when you are leaving Moleville, you will multiply. If you're traveling to Moleville, you'll divide. So when we do these problems, if you're going from mass to moles, then you would divide by the periodic table, the molar mass. So that's kind of how the map looks. But let's see this in action. Alright, here's our first question. It says, what is the mass of 0.397 moles of ethyl chloride? Now the first hint I'd like you to notice is I gave you the formula for ethyl chloride. If I give you the formula for ethyl chloride, that's my way of saying yes, you're going to use the periodic table, because at this point you don't know the formula for ethyl chloride. But let's look at dimensional analysis first, a way that we can solve this problem. I have 0.397 moles, and I put that over 1, and then I'm going to use a conversion factor, and moles has to be in the bottom in an effort to convert moles into what we want to convert it into. So crossing out moles, I can switch this to grams mass. And when you see that, you see grams over moles. And grams per mole, that is our unit for molar mass. And so we know that we are going to get that from the periodic table. So on the periodic table, I've got 2 carbons. They're each 12.0. I've got 5 hydrogens, which are each 1.0. And I've got 1 chlorine, which is 35.5. So when I add that all up, it's 64.5 grams per mole. So when I put that in my conversion factor, the 64.5 goes by the grams, and that's per 1 mole. Every time we use the periodic table for molar mass, that is 1 mole. Now when we're doing these problems, a rule of thumb is, as it says in your notes packet, when we answer these problems, round your answers to the same amount of numbers as the given measurement. We will have specific ways that we round our answers with more detailed rules later, but that's a good rule of thumb. So 0.397 moles, that's 3 numbers. So I'm going to give 3 numbers in my answer. So when I calculate this, it comes out to be 25.6 grams on the calculator. Now if you're going to use the map to Moleville, that's fine. The way that looks, if we look back at our map, I've got 0.397 moles. I want to get to mass. So what that tells me is I'm going to multiply by molar mass. That's how I get from moles to mass. And so on paper, I would take my moles, 0.397, multiply by molar mass, and when I do that, I'll get the same answer, 25.6 grams. So dimensional analysis is definitely one way to do it, as is map to Moleville. Either way, you got to show me your work when you're doing questions like this. Let's look at one more. This one says, how many moles is 58.7 grams of silver? So again, I can do dimensional analysis. 58.7 grams of silver over 1. I need to change my grams to moles. So I set up my conversion factor. And even though it says moles over grams, it's still a ratio of grams to moles. It's still using the molar mass from the periodic table for silver. And when I look up there, rounding to the 10th, it's 107.9. So now, again, make sure you put the number in the right spot. It's 107.9 grams per 1 mole. Mathematically, that's going to put 58.7 on the top, 107.9 on the end. I'm sorry, on the bottom. So now I have to divide. There's 3 numbers in my starting measurement, so I'm going to answer this 0.544 moles. On the map to Moleville, again, this time I have 58.7 grams. Here, I clean that up for you. Again, I have 58.7 grams, so I'm in Mass City. I want to know moles, so I'm traveling there, and that tells me I need to divide by my molar mass. So on paper, I've got 58.7 grams of silver divided by my molar mass of silver, and again, I'll get my same answer, 0.544 moles. Converting between mass and moles is a huge part of stoichiometry, probably the most important part of chemistry conversions. So again, you can use dimensional analysis to show me the work, or you can use this ratio, knowing that you've used the map to Moleville. But either way, that's how we convert between mass and moles in chemistry.